Hi everyone, this is Dr. Rajyalakshmi, Associate Professor, Department of CSE. Today I am going to discuss about integrity constraints in DBMS. Why we are using this concept in DBMS? Normally, we are inserting so many values into a database. Whether the data is properly inserting or not, that means whatever data we are inserting, the data is correctly inserting or not. That verification process can be verified with support of our new concept that is called integrity constraints. First of all, what is meant by an integrity constraint? Integrity constraint is a condition that ensures that correctly inserting values inside the database or not, that can be verified. So, what are the main factors included in the integrity constraints concept? Normally, suppose if we are maintaining student database. In that student database, what are the main factors we have to include? Student, under student database, student roll number, student name. Suppose if you consider these two fields as a column for the student database. In this, the student roll number is the main uniqueness value for this entire database, student database. Suppose in the first row, I am inserting 23211, okay, 5A0. Suppose if I am inserting. In one row, I am inserting this value. In the second row, the same value I am inserting, okay. Suppose without constraint, if I create a table, automatically these values are inserting. The same A0 value repeating multiple times. But in the every classroom, the student must have only one unique number. Every student identified with the unique roll number. But no student have same number. We cannot assign the same number to more than one student. But without constraint, if you create database, definitely the same number is allocated for multiple students. This is not at all correct. Okay. So, what integrity constraint says that whether the data is correctly inserting or not. That verification process can be done with support of integrity constraint. Integrity constraint is a condition that ensures that correctly inserting values inside the database or not. That can be defined with support of our concept that is called integrity constraint. So, the integrity constraints are how many types? Integrity constraints are domain constraints, entity integrity constraints, referential integrity constraints, key constraints. Every constraint having uniqueness, that means every constraint having some special properties. So, we can easily differentiate from one constraint to the another constraint. So, the first we are going to discuss about domain constraint. Domain means what? Suppose here I am taking student. Under student, SID, yes name. These are the columns presented. Under SID, suppose if SID mentioning varchar data type, varchar of 10. Okay, that means whatever any column name assigned with data type size, that is called domain. Okay, the domain constraint says that whatever data type mentioned for that particular column, in that only those values are acceptable. Okay, the set of values what we are inserting, the respective data type values only insertable. Normally string, character, number, date, these are the different types of data types are acceptable. Okay, the value of the attribute must be available in the corresponding domain. Okay, suppose if I am assigning SID comes under varchar data type. instead of varchar, if I am entering number value, okay, so it is not at all acceptable. Coming to this table, see here student ID, name, semester, age. Okay, see here, these are the columns presented in a table. Under age column, okay, age assigned as a number data type. Instead of number, if you assign character, okay, so integer or number data types are same. Instead of that, if you are entering character data type, A is the character data type, these values are not acceptable. Whatever values we are inserting inside of this column, number data type or integer data type only acceptable. Other than if you are entering, those values are not acceptable and it can be opposed because of one constraint. This is called domain constraint. Okay, the domain constraints can be defined as the verification of the column data types, whether the values inserting inside of that particular column is in the given range of the data type or not. That verification process can be done with support of domain constraint. Okay, is it clear? Domain constraint. Coming to the next constraint, entity integrity constraint. Entity. What is meant by an entity? Entity is an object that is distinguishable from one object to the other object. Suppose if we are assigning any constraint, any condition for the particular entity, those constraints are called as a entity integrity constraints. Coming to this one, here employee table. Under employee table, employee ID, employee name, employee salary. See here, employee table. This is a schema. Employee ID, employee name, salary. Right? These are the values. So here, whatever columns we are representing inside of the database, this is the schema of the employee database. Okay. So my table name is employee. In this here, I am assigning employee ID as a constraint, primary key. Okay, if you are assigning primary key for this particular column, it does not allow null values. It does not allow null. It does not allow duplicate. Okay. So in the first row, you can see 123 job, okay, 30,000 salary. So employee ID, the same employee ID, if you are entering one more time, okay, it is not at all. Suppose if I am entering 123, it is not acceptable. Okay, why? Because it does not allow any duplicate values. At the same time, it does not allow any null values. Null values nothing but see here. Here I am leaving this space, this column as an empty space. I am not inserting any value here, so that it can be treated as a null value. Okay, if you are entering null value, those values are not acceptable. Why? Because the employee ID assigned as a primary key. What are the properties of the primary key? It does not allow any null value. It does not allow any duplicate value. If you are entering null value or duplicate value, it is not at all acceptable. Okay, if you are assigning constraints for entity inside of the entity set, such constraints are called as a entity integrity constraint. It ensures that whatever values we are inserting, those values are correctly or not. That can be verified by the entity integrity constraint. Okay, so these are the examples for the entity integrity constraints. Coming to the next constraint. What is the next constraint? Referential integrity constraint. What is meant by referential integrity constraint? Referential integrity constraint nothing but it will create reference from one table to the other table. See here the table 1, table 2. We are establishing relationship between these two tables with support of department number. What is the main feature of the referential integrity key constraint? The referential integrity constraint mainly concentrate on what reference table will be there. Those tables must have the common column and must be defined with primary key. Okay, then only with reference of that common column we can establish relationship between these two tables. Okay, so one table acts like a parent table, another table acts like a child table. Okay, so relationship established like a parent-child relationship. Whatever properties we are inheriting here, the parent properties are inherited to child. Okay, this is the foreign key. Department number treated as a foreign key. Okay, so how we are assigning the foreign key of department number references. Okay, table 2 of table 1 of department number. Foreign key of department number references table 1 of department number. That means, so the table 1 foreign key, table 2 foreign key refer to the table 1 foreign key constraint. Okay, it can establish. See here in the primary table department numbers are 11, 24, 13. These are the acceptable department numbers. Okay, the reference table having 11. Okay, the first row having 11. Whenever I am entering 11 as a D number in the foreign key table, it automatically verify the respective value presented in the primary table or not. Yes, 11 exists. This row is acceptable. Coming to the next one, 24. If I am inserting 24, whether this 24 is presented in the primary table or not. Yes, 24 will be there. This row also acceptable. Coming to the next row, I am inserting department number as a 18. Is it acceptable or not? Here, there is no 18 inside of the table 2. So that this row not at all eligible. It will not allow 18 as a department number for the reference table. Why? The parent properties are inherited to child table. In this, the parent table doesn't have 18. It does not have 18. But here I am inserting 18. So, this insertion is not acceptable. Why? We are concentrating on the referential integrity constraint. What is meant by referential integrity constraint? We can establish references among the tables. Okay, if you want establish references among the tables, so what are the tables? You should refer all the tables must have common column. In the given example, department number as a common column. Whatever values exist in the department number, the same values in the primary table 2, the same values are accepted by the table 1 department number column values. Other than these values, if you are entering, those department numbers are not allowed here. 18 is not presented in the table 2. So that this row not insertable. Okay. So this is the foreign key constraint. Referential integrity key constraint. Whatever values we are inserting inside of the reference table, always those values are redirected to the primary table. What column? Through what column we are referring? The same values are presented in the reference table or not. Okay. In the reference table, if you are entering any new table, new value under the reference column, that value must be verified with support of the primary table referenced column. If those two values are not matched, automatically the row will not acceptable. Those values not acceptable inside of the foreign key table. This is the importance of the referential integrity constraint. Okay. So, a referential integrity constraint specified between two tables. Okay. So, whatever column value we are referring, that value must be primary key column. With support of reference, we are referring the primary table values. This is the importance of the referential integrity constraint. Coming to the next one, key constraints. What is the importance of the key constraint? What is meant by key? Key nothing but what? Unauthorized access opposition can be done with support of key. Why we are using key constraints concept? Unauthorized values entering into the database in some situations. Those insertions can be opposed. Those values defined by the key constraints concept. Okay. Key constraints consist of the set of rules. It identifies an entity within entity set uniquely. So, if you want identifies the uniqueness of your entity, definitely we should define key constraints concept. Coming to one example, suppose I am maintaining student database. Under student database, roll number always unique, name. Okay, my roll number is the unique for each and every student in a classroom. Each and every student having unique in the entire college itself. Suppose if you want to identify your uniqueness with support of roll number only, we can define. Such uniqueness defined by the key constraints concept. Okay. How many types of constraints are there? See here, not null, unique, primary key. Okay. These are the main constraints we are using. First of all, what is meant by not null? Not null is nothing but what? Every student assigned with name. Okay. Suppose if you want insert, if you are not inserting value for the name column for the student, automatically it can give the error to the user. So, if you want assign, create table student. First one is ID, integer 6. And what you are mentioning? Not null constraint you are assigning. What is the meaning of this constraint? If you are assigning this constraint for this ID, whatever values you are inserting, those values not null. Definitely you should insert value inside of this column. That is the meaning. Coming to the next one, name. Name comes under character data type, varchar data type, and it also comes under not null. Definitely we should define name column with value so that not null will work. Address varchar. So this is the not null key assignment. If you are entering null value, automatically this value can be opposed. Coming to the next one, unique. Unique is nothing but what? Whatever values we are inserting, those values are the unique. Okay, suppose the same value, suppose in the first row I am inserting 123, in the second row also same 123 I am inserting. This can be opposed. Why? Uniqueness. It must specify the uniqueness. It does not allow the duplicates. Unique, create table student, ID integer 6. I am assigning not null plus unique. So, it doesn't having null value. At the same time, you should maintain unique value. Name, varchar, address, varchar. Okay. Like this way, we are assigning constraint for any table. That is called the unique constraint and not null. Along with these two, we can create a table. Coming to the next one, primary key constraint. What is the meaning of primary key? Primary key nothing but it does not allow any duplicate values. It does not allow any null values. You can see so many applications are there. Some of the application fields are red mark fields are there. Those fields are treated as a mandatory fields. Okay. If you assign star mark for these particular fields, it does not allow any null values. It does not allow any duplicate. Whatever values you are inserting, those values must be uniqueness. Okay. The primary key, how we are assigning. Primary key of create table student, ID integer, not null unique, name character, address where. So instead of this, directly you can give primary key of ID. Automatically whatever value we are inserting, those values are verified by the primary key constraint. If you are inserting at any moment null value, it does not accept. If at any moment you are inserting duplicate, it does not allow. This is the speciality of the primary key constraint. Unique plus not null equal to primary key constraint. Okay. Coming to the next one, foreign key constraint. The foreign key constraint is also called as a referential integrity key constraint. It can refer one table values with other table values. If you are assigning any table, suppose this is the table 1, this is the table 2. You can see, you can imagine it. Okay. Suppose here SID, here also SID will be there. Okay. So in the table 12, 13, in the case of this is the reference table, this is the foreign key table, this is the primary table. If you are inserting value 12, it will be redirected to this 12. Exist this row acceptable. Suppose if I am inserting 15 here, it will verify there is no 15. This row will not acceptable for the T2 table. Why? The foreign key table is the reference table. What value you are inserting here, those values must be verified with the primary table. The respective value not presented here, 15 not available here. So, the parent properties are inherited to child. Parent-child relationship established with support of the foreign key constraint. So that the foreign key constraint is also called as a referential integrity key constraint. Okay. So coming to the next one more constraint, a few more constraints are there. What are those constraints? See here, check constraint. What is the meaning of the check constraint? Whatever column value we are inserting, those values range we should mention. What is the meaning? Suppose I want to create voter list. Okay, voter list of the public. So every voter having Aadhaar ID and next constraint is age. Whenever age is greater than 18 or equal to 18, those values only acceptable. Suppose less than 18 column value presented in that voter list, those values are not acceptable. Such conditions we want to keep inside of the voter database. How it is possible? Such type of verification process can be done with support of a new constraint that is called check constraint. Okay, where age greater than or equal to 18, then only those values acceptable under age column. If less than 18 inserting, automatically it can be opposed. Those values are not inserting in the table. See here, if you want create student table, ID, integer, data type, size 6, not null constraint, name varchar of 10, not null. Coming to this one, age, int, data type, not null. Definitely you should define with some value, and you are check age greater than or equal to 18. What age value you are inserting, that value must be greater than or equal to 18. Those values only acceptable under age column. We are checking the values of the age. What is the condition? Greater than or equal to 8. With support of check constraint, this type of verification process can be done. That is the importance of the check constraint. Is it clear? Coming to the next one, default constraint. Default constraint is nothing but, suppose if you are not inserting value, by default that value must be 18. Such insertion is possible, that creation is possible with support of default constraint. Okay. So, if any situation, if the value not inserted by any user, defaultly that value specified as a 18. So, that can be possible with support of one keyword, that is called default constraint. Okay. So, this constraint is used to provide a default value for the field. That is the main importance of the integrity default constraint. Okay. So, primary key constraint, default constraint also play a major role for the getting of the correctly inserting values into the database. These are the integrity constraints in a database. Coming to the next topic, database administrator. What is the speciality of the database administrator? The database administrator is the specialized person. Why database administrator treated as a specialized person? If you want control the entire activities of the database inside of any organization, suppose if you are working with company, in the company environment, whatever data we are using, the entire data can be maintained by the database administrator. Okay. In our college also, the total entire organization database details maintained by the database administrator, so that the database administrator is the centralized person for controlling the entire activities of the database system. What are the functionalities of the database administrator? The database administrator functionalities are storage structure and access method definition. What storage allocated for that particular database creation. Okay. What access methods we are using for the accessing of those storage details, that can be defined by the database administrator. And coming to the schema and physical organization and modification. The structure of the database defined by the schema, and how many disk capacities available, disk storages are available, that can be defined by the physical organization and modification. The structure of the database and the internal storage details defined by the database administrator. So, schema and physical organization modification, that is also one of the most important functionality of the database administrator. Granting users authority to access the database. If you want access any data inside of the organization, anybody easily cannot access anything. If you want access anything, we have to log on to some username and password, then only we can access the data inside of the organization. That can be defined by the database administrator. Granting users authority to access the database. Without granting permissions, we cannot access any system inside of the organization. so that granting users authority to access the database. Coming to the next one, backing up the data. We are providing recovery purpose. Okay, backup system we are providing. That means suppose 3 months data we are located in one backup additional storage that can also be maintained under the routine maintenance. Okay, whatever data is there, 6 months data, the data can be located inside of the backup systems. So that can also be provided by the database administrator with support of the backing up data. Coming to the next one, monitoring performance and responding to changes. Monitoring performance nothing but whether the internet speed is properly maintained or not. All the memory slots are allocating perfectly or not. That monitor can be done by the database administrator. Database tuning, that means how much space is allocated. Suppose beyond that level, the space we want to access, okay, cleaning the data, and we are allocating data to the new users that can be defined by the database administrator. So these are the functionalities of the database administrator. Coming to the next one, database system structure. What is the importance of the database system structure? The database system structure mainly concentrate on the first one is users. Second one is interface. Third one is query processor module. Query processor module. Fourth one is storage manager module. Okay. Last one is disk storage. These are the blocks available inside of the database system structure. The naive user, that means this person doesn't know the technical details. He can interact with the database by using application interface. You can see ATM users. All the ATM users interacting with the ATM mission. Okay, interface is ATM mission here. By using guidelines, they are following how to insert card, how to retrieve money from the mission, like that. Coming to the application programmers. These programmers interact with the database by rating of the application programs. Okay. Coming to the next one, sophisticated users. The sophisticated users using query tools. They are the highly professionals. They are the very experienced professionals. Inside, that means after 5 years or 6 years, those comes under sophisticated users in the company environment. They are not writing fundamental code. They are utilizing query tools. They are using query tools to interact with the database. All the stock market analysts all comes under sophisticated users. All the basic programmers comes under application programmers. Coming to the database administrator. This functionality already discussed in the last slide. He is the centralized person to control the entire activities of the data inside of the database with support of administration tools. These are the very important blocks. Coming to the next one, in the query processor module, whatever interface mechanisms are there, application program object code for the Navy users, compiler and linker, DML queries, DDL interpreters, all are communicated to the query evaluation engine. What it says that in different formats, different users interacting with the database, all the queries processed and evaluated with support of query evaluation engine. The query tools move to the DML query, data manipulation language queries. This can be recognized by the data manipulation language compiler and organizer that can be passed to the query evaluation engine. Okay, suppose if I am asking select star from tab, select star from student. If I am asking, this query can be evaluated through DML compiler and organizer. Select command. User is asking selecting. That can be defined by the query evaluation engine. Okay. The entire meaning of the respective query can be defined by the query evaluation engine. The respective data located in what location? Different managers are there here. Buffer manager, file manager, authorization and integrity manager, transaction manager. Okay. So, the respective student table is located on which file organization. Okay. That can be defined by the different managers. File manager will says that where that particular student table is located inside of the disk. Suppose the buffer manager says that at what location that can be located on the disk. Authorization and integrity manager says that accessing permissions for accessing of the student database. The transaction manager says that what data you are asking all can be done through transaction management. Okay, coming to the next one, disk storage. This is the very large storage capacity disk. Inside of the disk, the data can be stored in the form of statistical data format, data dictionary format, indices, data. Okay, indices nothing but suppose large number of files are there. All can be created, sorted in the form of indexes. Data dictionary nothing but every database meanings defined by the data dictionary. Statistical data nothing but the comparatively from one year to other year, what is the population in Indian country. If you want to verify those data, statistical data can be stored inside of this statistical data block. These many types of details we can maintain inside of the disk storage. Like this way, we can access user to the disk storage with support of the database system structure. So, these are the concepts presented inside of the database system structure. First block is users, second block is interfaces, third block is query processor module, fourth block is storage manager module, last one is the disk storage. These are the important blocks presented inside of the database system structure. So, this is the overview of the integrity constraints, database administrator and database system structure. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.